that I wanted to quickly do, which is cybersecurity capabilities of IEDs. See, we talked about the cybersecurity of the network and the whole system, but individual device we did not talk about. So this is an IEEE standard. There is no IEC standard on this. This is actually a recent one. IEEE standard, which is standard for IED cybersecurity capabilities, focusing just on IED, right? So, so this is the purpose and scope of this standard. It is focusing on, you know, access control to the IED, controlling the access to IED. Some of these will sound very familiar, but they have put it all together specifically for IED. And then authentication and authorization, event logging. So in a way, what they are trying to do is making sure that the IED manufacturers include some of these features within the IEDs. Okay, although they are obvious and we know about these. Uh, so secure firmware and configuration management. So all these practices should be there. And physical security attributes. Okay, system hardening and key management. If we are using the key infrastructure. Okay, so it doesn't dictate the architecture. It doesn't say, ID should have a particular architecture. All it does is it defines the capabilities, as I said, that ID should have these capabilities so that these aspects can be supported. Okay. So this is again why it matters, especially from the regulatory framework. For in North America, we have the NERC-CIP regulation. So you have to meet that, and that regulation actually dictates that some of these capabilities be there. And I'm sure, again, from the Indian context, there may be a regulation like that also. Okay. So, and at the same time, it reduces the risk of unauthorized access. So it's, important from cybersecurity point of view also. Okay. So what is included in this standard? All the IDs. So any microprocessor-based device that monitors, controls, and protects electric power system. So everything that falls within that category is included in there. Okay, which includes even fault recorders, all and merging units. Okay, sometimes we think that IED is just the protection relay. Okay, so intelligent electronic device is including all these way controllers, transformer differential relays, feeder protection relays. So all type of protection relays along with the newer merging units or fault recorders or bay controllers. Okay, and what is a cyber access? Okay, any device that uses computing or communication capability and is network connected. So that's what they say. Um, so let's talk about the access levels. So there are 4 access levels defined. Unlike role-based access, this was one of the gaps in IC 62351, right? We talked about that yesterday. That it doesn't really define the levels and who has access at what level. This standard does, for at least for IEDs. Okay, no access, which is public access. It can only read the status. Observer, view only access. Okay, status means whether it's on or off, or just very simple information. And then we have the operator that can execute some operational commands. Okay, then engineer or admin, which has the full configuration rights, can update the firmware, change the configuration, and so on. So it actually defines. So an example, if you look at particular relay, and this is again not that I'm promoting this relay, this is just an example. Okay, it's a observer, it can view only metering pages, right? So that's level 2. And then operator can issue a trip command. Engineer can modify the settings. So that's again the access. Okay, What are the authentication requirements? Again, some of these are very common sense things, right? Unique user accounts. So it shouldn't be a common username and password for 15 people, right? And I don't know, you guys tell me if in digitality that happens or not. Authentication for all access levels. It doesn't matter, whether it's a observer, there has to be authentication for that, right? And strong passwords, both in terms of length and complexity, and also password aging and lockout features. If you try 3 times, it should lock you out, for example, right? And after 6 months, password need to be changed, or after 1 year. I know it's a big pain. Okay, even in my computer, my IT department, every 6 months they badger me with emails. Your password will expire in 15 days. You must change that, right? Sometimes you don't like that, but from security point of view, it's important. So, for example, GE multi-nil relay requires a minimum 12 character password. So there is that length and complexity in terms, we know that you require a special character and so on, right? They 5 attempts they give, and also password can be hashed, right? Using, for example, HSA 256 or right, and then role-based access. We talked about that, right? So 4 levels we talked about. So, and then logging and audit trail. So this is again a requirement. ID must log, record all user attempts, any configuration changes, who did at what time, and so on, and what was changed, any firmware updates, and any operational commands. So at least for certain period of time, they should record, because this will be important from monitoring, security monitoring point of view also, so that you can pull out those logs, and if you have to analyze after the incident has happened, you can correlate that what happened at what time, at what level, at what device, right? So logs must include timestamp. So that's when you can, better correlate events. User ID, action taken, whether it was a success or a failure. Okay, this is just an um, audit entry from an ID. It basically says on this date, this time, this user changed the setting group A successfully, right? And so on. So you have, and this is again unknown user, login attempt failed. So this basically will tell you, if you get this from the log, it will tell you that somebody unauthorized is trying to get into your ID or into the system. Okay, so it will alert. So then you can start investigating where and how this particular user came into the system, right? So what are the electronic? So ID must be able to control and protect access via ports, whether it's a USB serial port or Ethernet port. Okay, so this is again some of the things, at least the work we have done, we found that ports are left open, right? So you should disable the unused Ethernet ports, right? Because your ID may provide you more than one port, okay? And it's actually notorious. They provide you multiple things that you don't even use or require, right? And then configure secure serial port access, USB port, enable disable by a policy. You may even say no USB allowed, okay? Because malware and all those things are usually transferred via USBs, okay? Then firmware management is another one, secure firmware management, okay? Cryptographic signing of the firmware, integrity check before installation. Some of this is already there. Actually, the manufacturers are doing this, okay? And prevention of downgrade attacks in this case, okay? So this is another example, unless it's signed by the ABB's private key, right? So you could verify whether the firmware you are trying to upload or change into a relay, is it properly signed? Okay, when we talked about the signatures, the digital signatures. Okay, and then file management. Okay, ID configuration files should include all these, right? So it requires secure file transfer, HTTPS, via the TLS mechanism, so that you securely do the transfer. Access control and cryptographic integrity validation, right? So all that. So this should be the mechanism: verifies the permission, checks the file signature, logs the change, activates the new settings, right? Again. And then there are physical security requirements. Okay. IDs must include physical such as tamper detection. I'm not sure if any IDs currently has that tamper detection. Okay. Just out of interest, curiosity, I have a project going on right now with, this is undergraduate students. They do the final year project. So it's on smart meter tampering, anti-tampering device for smart meter. I have given them a challenge that produce a device that is less than $15, which can detect if anybody is trying to tamper with the meter and then send a message to that, right? So it's actually, they're using very simple technologies in there. You can use the vibration, because if somebody is trying to tamper, your ID will vibrate actually, right? And sometimes they will use the magnetic, very high powered magnet. So you can use, magnetometer type. And those sensors are like $1 each. They're not very costly. And then just put together something like that, right? But I'm not sure if IDs has that, if somebody is physically trying to tamper, okay? And then there are hardware switches so that settings can't be changed. If somebody tries to get into the system, even if they got into ID, they can't change the settings because you have, physically disabled that, right? And another one is, it doesn't mandate specific algorithms for cryptography, okay, but it requires the devices to support that. And these are again typical installation implementations, right, that are there. And then interoperability, with obviously all these meeting all these standards. And as we were talking about for India, actually this is now mandatory, has been mandatory for some time. Any device coming in must meet this standard, right? So these are again some of the examples, okay? How, if you are meeting this standard, how it will mitigate some of these scenarios. If attacker tries to modify the settings, then how it will mitigate that, right? And so on. So I will not go through this. You will get a copy of this one, okay? But let's talk about limitations. Obviously, the standard has limitations, okay? It doesn't define the network architecture, doesn't enforce specific protocols. It basically, gives you the requirements. It's up to the user to do that, and provides capability, not detailed guidelines implementation, and does not cover system level security. And it's okay. I don't think this is really a limitation, because it's only meant to cover for IED. System level, we already talked about IEC 62443 segmentations and so on. Okay. Okay. Any questions on this before I move on? So I thought very quickly we talk about, because we have talked about system level security a lot. We didn't talk specifically device level security. Okay. And this is the only standard, as far as I know, that covers that thing. So any questions on this? Good. Okay. Okay, so we will talk about the intrusion detection system. So rather than using the presentation, I also have a presentation on this PPT. I thought it's better to just use the Word. I put everything in Word, right? Because you are going to get this. Okay, so we will just go through this because also given the time, if I start using PPT, it takes much longer time than usual. So we will. So intrusion detection system, I specifically are talking about the OT networks, okay, which will include, power systems, substations, as well as industrial control system. It's equally applicable to both of those, okay. Um, it's not, there are some differences from IT networks. I'm sure you are aware of that, okay. So OT systems, so for IT network, your IDS doesn't have to be there 24/7, right? Whereas for OT, this is actually one of the requirements that it must be, available, okay? And also the protocols are different for OT systems, right? So it must be able to work with those protocols. This is actually one of the big difference between IT and OT. Um, and we do have some open source. We will talk about those tools. There are some open source tools. Actually, I may give you a paper that we did way back developing an IDS where we use the open source tool to develop that. Okay. But there are now commercial ones available also. So we will talk about that. Okay. So what is an IDS? It's nothing but a security monitoring tool, basically, that is going to inspect the network. Okay. It's going to basically analyze the traffic. Okay. So that it can detect any behavior or policy violations, right? If anything unusual activity happens, then, and also for OT networks, we cannot have active IDS. We always have passive IDF. Passive means that it's analyzing the information kind of offline. Okay, it's not interfering with the operation of the system itself. Okay, so it's a passive. It's just sitting there, passive, or sometimes we call it out of band. Okay, which is listening to the network, and then, usually it's by mirroring the ports. So what it does is basically mirrors the port. That means whatever is happening at one port, it will be copied, and same traffic will go on the other port, and then you sit there and analyze that. Okay, so that's what. Now there is another thing called um, intrusion prevention system. Okay, which is more active actually. Okay, we are not going to be talking about that, but I thought I mentioned it here. Okay, it's closely related to IDS. It does similar thing, but it's much more active, and it has active blocking capability. IDS will not block it. It will basically detect it and inform you. Okay, whereas IPS, intrusion prevention system, is actually going to block it for you. Okay, it's much more active, and it's an inline device. Okay, that can drop or reject packets which are deemed malicious. Okay, so it's much more active, whereas IDS will detect those type of packets and inform you. It's not going to block them, and it will not be able to prevent real-time attacks, IDS, whereas IPS can prevent real-time attacks, okay, because it's active there, right? So IDS is usually for initial deployment. Once you become comfortable with IDS, maybe you will feel comfortable enough to say, okay, now I can go with the active one, with the IPS. But you have to remember that sometimes there are false positives and false negatives. So it's going to start impacting your operation also. Okay, so those are again the decisions that has to be monitored. So This is detection only. This one is prevention, active prevention. Okay. So we already talked about the requirement for 24/7, also the proprietary industrial protocols, which are different than IT. We already talked about. So OT has to be, capable of doing that. Okay. So obviously, then you have to tailor all these technology for these OT protocols. Okay, so that you can, properly inspect the packets, which obviously are directly tied to your protocols, right? So what are two different types of IDS that we are going to talk about? So there is a network-based IDS, okay, which obviously monitors the network traffic, okay, across, either a part of the network, if you are especially using segmentations, right, or the entire network, okay, if it is a flat network, right? So it basically inspects the packets for any suspicious signatures or anomalies, okay? So it's typically, we already talked about, typically um, it's like a sensor, okay, where you will extract the, mirror the port, okay, and you will be, IDS will be connected to one of those mirror ports, and then you will basically see exactly same activity that's happening um, on the other ports, right? So you will passively analyze the communication between various components, PLCs, RTUs, HMI, and so on, okay? So this is actually the one that's, wherever it's used, this is the one that's commonly used, especially for power systems, because you can understand the issues with the, with the host based. We don't have the capability, whereas the host based runs on individual host. You may run it on a server or on a device, for example, IED. Okay, there is research going on where there, some lightweight type of IDSs that can be deployed at various places within the network. But the current practice is to have a network-based IDS, right? So let's just quick comparison between the two, okay? Um, so scope of monitoring, if we look at this one, network-based ID is going to monitor network packets across segments, okay, which can be communication between devices. Whereas host, it will monitor the individual host activity, okay, which could be logs, files, processes, and it will see only local events, not the whole network, right? And the deployment target, in this case, it's a dedicated sensor hardware or a virtual machine, which is attached to the network via, a tap or a port or a, this is span is the type of a port. What is the full name, Somya? It says it's actually Windows. Microsoft has given it a name, span. It's nothing but a port, okay? And there is no software on ICS devices. Devices are left alone. The whole network is left alone. It's just a tap where you will monitor the traffic. And switch port analyzer. So it's just a name. Actually, it's a name given by, I think, Cisco, not 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 Microsoft. Cisco have given it a name, span. And so here you will have that implemented on the host itself. So obviously it requires the compatibility with the host operating system. Okay. OT uses consideration passive, okay, where you just want to monitor but no impact on your operation. Okay. Here, the host base, it's limited, only feasible on certain Windows Linux right now, right? And then what are the detection capabilities of this one? So any network-borne attacks, any attack that happens over the network, it can detect, okay, any attack which is host specific. For example, somebody just attacking your ID, right? So it can detect that, right? So we will talk about this, okay? So these are the packages or tools I was talking about, Snort or Suricata or G, right? And the host-based ones are, this is actually OSECC is an organization, okay? We will talk about that also later on, or an EDR or agent on server, okay? So as I said, in power systems, this is what's mostly used right now, okay? On the individual one or not. So obviously, both of these will contribute to your intrusion detection strategy. So as say, start with the NIDS, network based, to gain, experience and confidence and so on, and then you can move on. Even just having this network based intrusion detection system actually can help a lot in the cybersecurity. So what are the various approaches that are used? Okay. So detection techniques, there is a signature based detection. Okay, what it does is it has a database of known threat pattern, which are called threats. Okay, right? Any new one which is not in the database, it's not going to be able to detect. Okay, actually, the manufacturers of commercial IDSs are going to provide you with that database, and also they update the database regularly, just like um, the companies providing, for your PCs, antivirus software. Okay, any known threat comes, they will update your antivirus software. So exactly same way. So the signature based is obviously it relies on a database of known threat patterns. Okay, which could be a specific sequence of malware, payloads, suspicious protocol commands, and so on. And what are the pros and cons of this type of strategy? It's very fast and efficient because all you are doing is pattern matching with your database, okay, which is already preloaded, right? And it's well suited for malware exploits rule-based policy violations, which are known threats, basically. That's and it will have a low false alarm rate because it's matching concrete, right? So you are basically matching exactly what you have in the database. But again, the con is it cannot detect any novel or unknown attacks. Anything new attack that comes, which is not in the database, it cannot. So obviously, you pray and hope that it happens to somebody else, and from there it will get into the database, right? So, so anything without a signature is going to go unnoticed. So it obviously requires a continuous updation of the database. But as I said, the manufacturers of these commercial ones that they provide IDSs, they try to update that. Okay, the other technique which is used is what we call anomaly-based detection. Okay, yeah. IDS can be, sorry, IDS with firewall. Oh, firewall and IDSs are two different things. Oh, do we sync the detection? So firewall is basically allowing, um, you know, um, the role of firewall is basically to block and allow, right? whereas the role of IDS is to detect any malicious activity. So if you have detected a malicious activity, okay, and then you analyze it, and you found out it's coming from a particular, say, source, okay, then obviously you will take the action, whatever actions need to be taken, because that's the whole idea of IDS, especially the passive ones, okay. So anything is detected, it's not going to stop. What you have to do is take that information, analyze it, okay. We will talk about the signs, okay, security monitoring. You analyze it, and then you take whatever actions. It could be a firewall, it could be something else, those actions has to be taken. IDS can do, IPS can do the blocking, yes, but as we talked about, there is a danger, right? If it is a false information, then you may end up blocking legitimate, operation, which can jeopardize, you know. So so IPS in utility context, I don't think people are using that. Okay, actually, many people are not even using IDS. Yeah. Yeah, but IPS is firewall cannot block some of the network traffic. Okay, let's say somebody got hold of credentials, right, of one of the legitimate employees through phishing or whatever, right, and then they will go through firewall, right, but IDS will catch it because they are trying to do something which they are not supposed to, right. IDS will catch it. So this is more behavior anomaly based approach. It's normal behavior for network. For example, if you analyze a typical traffic pattern or a command sequence or throughput, okay, so anything which is of normal behavior, you will see, which is harder to set, but over time, your system, right? And you will know that what is the normal traffic patterns in your system. If you suddenly are getting a huge amount of traffic in, say, particular area, right? Then you start suspecting that something is going on, right? So this is more of a behavioral thing. So what are the pros and cons in this one? Okay, it again can detect, in this case, that's a big difference. It can detect 0-day attacks that don't match any signatures, right? Because it's not based on pattern matching, right? It's really based on the behavior, right? Um, so that's the big difference. So in OT, it can catch subtle issues like a attacker toggling a breaker outside of normal operating hours. You know that this particular breaker you normally operate between this time, right? So if somebody tries to operate it in a different time, then obviously it's an abnormality. It's a abnormal behavior, right? And for some um, for some cases, it will work very well because majority of the utility operations are very predictable, right? Simple example, if you see a lightning struck storm approaching, then obviously you expect that there will be some breakers opened and closed, right, at that time. So that's a normal behavior. The con is false positive, okay? That's again, which are not anomalies, right? Because all anomalies may not be attacks. That's another issue. So that's again a big con of here, okay? And improperly tuned, this is anomaly detection can overwhelm engineers with alerts, right? So what you can do is you may not, your IPS can be configured where you actually don't allow it to prevent something, but alert the operator, right? And then the operator can decide whether they want to take action or is it a false positive or not, right? So that's another way you can do that. So in summary, signature-based IDS, low false alarms, okay? It will catch known attacks very reliably because you have them in your signature database, but it's blind to any new threats, okay? And it needs the database update of signature. Whereas anomaly IDS, it will detect zero-day attacks, right? Because it's based on the behavior. And but higher false positive rate, it could become a problem in this case. Okay, so you could use a hybrid approach, okay, where you use the signature as a first line and anomaly detection for advanced monitoring, and also you don't allow anomaly detection to, should be analyzed basically, right? So this is again very quick overview of what we have talked about. Signature based, it matches activity, whereas um, you know right, very accurate for known threats, and it may miss unknown attacks, requires updating. Whereas the other one, anomaly based, as we talked about, is learns from the normal baseline behavior. Okay, network traffic volume, command patterns, or user logins, right? So you know who is doing what at what time under normal conditions. And if it becomes abnormal, then you can. So the weakness is it requires higher tuning effort and false alarm potential. So it needs a very stable baseline. You must know very well your normal, right? So let's talk about major tools. Okay, what are the major IDS tools for OT network, which are open source, and then we will talk about the commercial ones, at least some that I'm aware of. So there are three. Okay, Snort, Suricata, and Geek, which was formerly known as Bro. Okay, so those are the three open source, and you could use those to develop your IDS. Okay, in our study we have used Snort to develop an IDS. Okay, which is a signature based. Okay, network based IDS, which is signature based. So this is actually one of the oldest ones, has been around since 1990s. It's basically a rule driven language, okay, to define the signature, traffic signature. You could do that, okay. And as it's a open source, it's more community based, okay. So you have a large community maintaining rule set, even for some protocols, okay. So how does it work? Its rule engine is basically inspecting the packets for pattern defined in the rules, which you provide, the rules you can provide. Okay, so developing this is actually very simple. All it involves is you have to define your rules. That's it. Okay, you define the rules, and this one will basically go with those rules. And if those rules are violated, then obviously you have a issue. And its performance, it is a single thread. So that means it does the calculations sequentially. Okay, so it takes time. Okay, so it's not meant for very high traffic loads. If you have very high traffic load, then analyzing it will take a long time. Okay. If you have light load, because it's a single thread, it's more computing, single thread computing. So, right. So first, they have introduced Node 3 for multi-threading, but we will talk about Suricata, which was mainly developed for multi-threading. So that means it's much faster in doing the analysis. They have developed Snort 3 for using multi-threading. Okay. And how did you use it for, industrial control system or SCADA set rules? Some of the rules they provide actually. Okay. And also there are some protocols that they support already, Modbus and DNP3 and some other industrial protocols. Actually, we will see later on, the commercial ones support up to 500 protocols, different protocols. Okay, so including some of the ones we use in the utility. Okay, so what are the pros of this one? It's very mature, has been around since 1990. There's a lot of documentation and community support. If somebody wants to develop their own, there's a lot of community support, and it can integrate with many security tools. Okay, security monitoring tools, it can. Okay, what are the cons here? It lacks the native, so it's a purely signature based. It's not anomaly based. Okay, so unless you separately integrate it with anomaly, right? And single thread is a problem for large networks. It may take very long time to analyze the traffic in that case. Okay, and there is no graphical user interface. It's actually a very simple thing. So you have to, develop your own, or you have to get it from the third party. Okay, there is community GUI may be available, but again, they're not very sophisticated. These are those people who, as a hobby do these kind of things, right? So, so these are again some of the examples in OT environment. Small industrial PC you can develop for a small system, okay? And with the appropriate rules, you can detect, for example, patterns, some of these Modbus commands and so on, okay? And again, you need to maintain your rule set yourself, right? The second one, which is open source, which is a multi-thread, is called Suricata. Okay, it came about in 2010, more recent. Okay, it's designed by Open Information Security Foundation. This is a organization. Okay, it has same, snort rule syntax, but adds additional capabilities. The big difference is really the performance, because it's a multi-thread, so it can run on multiple CPU cores to process the traffic in parallel, okay, rather than a single core, single thread, okay. So it obviously then you can run on larger networks, okay. So the detection engine in this case is again signature based, but there is some built-in capability, okay, uh, where you can have a little bit more complex logic, which you can add yourself. But primarily, it's a signature-based thing, okay? So the protocols, for example, number of protocols, the common ones are there as well, but there are custom rules for some of the protocols that you can develop yourself, right? So that's the Suricata. Okay, what are the pros and cons of this one? Multi-thread for scalability. So larger systems can be accommodated. Okay. Um, Snort rules, rule repository is there. There are additional features. For example, TLS certificate logging it can do, HTTP request logging it can do. So there are additional features above Snort. Okay. The cons, heavy resource usage per sensor because it provides many features there. Okay. Let's talk about the next one, which is the GEEK, which is formerly known as BRO. It's actually one of the most powerful open source ones that is available. Okay. GEEK is behavioral. Remember, we talked about the two types, signature based and behavior. This one is behavior based. And it's not signature based, not primarily signature based, but it can inspect the traffic at a deep level. So obviously, it can do the behavior analysis. Okay. It can do dozens of protocols. So it's, the scale is much larger. Okay. Many application layer protocols as well. Okay. Not only the network type protocols, but even application layer protocols. Right. So, and it can provide the detailed log of all the sessions. Right. Now, what are the pros? In this case, rich analysis. Okay. Comprehensive logs for forensics, right? So that you can find out what's really going on. And what is the con? Very steep learning curve, not easy to use and learn. Okay, so that's again one of the cause, because it will require familiarity with the scripting and output logs and so on. So, somebody has to be expert in programming and understanding, right? Uh, Okay, so those are the three that I wanted to talk about. This is again very quick comparison of the three. Okay, detection style snort is signature based. Suricata is primarily signature based but has some capabilities of anomaly detection, whereas GEEK is mainly behavior analysis. Okay, this is single thread, multi-thread, and this one is very efficient event engine. So similar to Suricata in performance. So it's good for smaller systems, okay, where you kind of know the signatures and so on. This is used for ICS monitoring because it can parse industrial traffic and supports the logging also. This is very powerful, and you can do the custom script. That's why you need to, learning curve is much longer in this case. Okay, this has been around for a long time, so it's proven, widely used for smaller systems, obviously. And there are many third-party integrations that will provide the GUIs and also SIME controllers, right? Um, this is obviously, parallel processing can be done in this case, okay? And this will produce very rich logs, not just alerts. It can provide you a lot of information about what's happening, right? So in general, if you are using Snort or Suricata, they are excellent for known threat detection because they are mainly signature based. GEEK is for behavior monitoring, right? But obviously, for GEEK, your learning curve is much steeper. Okay, the easiest one to use is the Snort. Okay, I think I will share with you the paper that we did. This was done even before anybody was talking about IDSs. This was, I think, the paper was like 2012, 13, 14 years back. I'll share with you what we did in that. I think, those of you who want to, understand a little bit more, I think it will be useful for you. Okay, let's talk about the commercial IDS solutions. There are number beyond the open source tools, purpose-built commercial platforms are becoming available. Okay, so they obviously include more functionality than IDS. For example, asset discovery, risk dashboards, and integration with your industrial workflows and so on, right? So the main ones, there are three leading vendors in this. And again, I'm not promoting any of this. I'm just giving you this for sharing the information. If you are thinking of doing anything, you have to do your own work. Okay. And again, I don't promote any of these. Okay. So just information sharing. Okay. The three leading vendors are Dragus, Nozomi Networks, and Claroti. Okay. So I will give you a little bit of information about each one of these. Okay. And these are mainly for industrial control systems. So Dragos platform, which is developed by a team of ex-ICS incident responders. So they know, what kind of incidents. So it is focusing on threat intelligence driven ICS monitoring. Okay. Um, so it will provide the visibility to your assets. As you said, that's again one of the features. It's a combination of signature and behavior. Okay, both. So there are signature database and also there is behavior analytics. Okay, so this is the one that we talked about, the hybrid combination. Okay, so this supports 500 plus industrial protocols. Okay, so a lot of protocols it supports. And it can do the deep packet inspection for each of those protocols. Okay, and then asset inventory, right, and so on. So the other one, Nozomi Networks, they have a Guardian platform. Okay, and again, they provide the visibility as well as anomaly detection. Okay, so they use machine learning and AI tools. And again, this is behavioral, obviously, right? Normal operation, right? They are using to model normal operation and detect anomalies. They also support 500 plus protocols, and asset discovery is there. Okay, and network topology. So they provide you a lot of visibility of your network along with doing the behavioral analysis. So obviously, the first one is hybrid approach. This one is behavioral analysis using machine learning and AI modeling. Okay. Then the third one, Claroti. Okay, that's another OT security company. What they call is they provide complete cyber physical system protection platform. Okay, so they do continuous threat detection, secure remote access, and so on, right? So 450 plus protocols in this case. Okay, asset identification is there as well in this one. Okay, it's both signature and behavioral based. Okay, combination hybrid also, right? So that's the third one. And then there are others. Okay, those were the three main ones that we talked about. There are others. Okay, and there are more coming. I know in India there are companies coming up also doing, security. So there is this one, Tenable.ot, formerly in Digi. I didn't hear any of those. And Foresight, inspect. There is another, and then obviously Cisco Cyber Vision is there, and Kaspersky Industrial Cybersecurity, and so on. So, you know, okay. So, what are the common features of the commercial OT IDS? Industrial protocol. Obviously, they support, as we talked about that, 500 plus or 450 plus in this case, and they have the ability to understand the protocols deeply, so they can analyze a deep analysis of the traffic. So, Modbus DNP3, IEC 104, and then some of the proprietary ones also, that companies use, right? And again, this is meant both for industrial control systems as well as utility systems. So this is a broad spectrum, and they can do handle asset inventory and baselining. Your normal baselining communication, maybe what they will do is initially they will just sit there and do your baseline analysis. Okay, what is your normal traffic, and then use that later on. Okay, and for signature based, obviously they are to provide the updates. Your database has to be updated. And then they have the capability for integration, right? So provide the APIs and integrate with your monitoring softwares. Okay, monitoring packages like Splunk and QRadar or ID ticketing. Okay, these are the packages that does the security information and monitoring, right? And then they will provide you the reports so that you can use those for compliance. Okay. Again, in North America, those are again the standards that are required, regulations. So they will actually produce those so that you can show it to the authorities that, yeah, we are compliant to that. Okay. So again, if you are thinking of using one of these commercial ones, I think things to consider is scalability, because eventually you may want to start small, but you may want to then go to, right? And obviously sport and specific protocol coverage. Are they covering your protocols that you are looking at? Okay, so let's quickly, we are already, I'm just looking at time. I still have one. We will see whatever we cover. Yeah, so I will go through this very quickly. This is again, something, deployment strategies, okay, network architecture and sensor placement. So this is, we know that we have segmentation and different levels, level 0 to 5. We didn't talk about that. This is again part of IC 62443 standard, where you have to specify for each device which level it fits into, whether it's a very high priority or risk. Based on the risk, you will go, they call it a Purdue model. You specify which level of security you go to, 0 or the 5, obviously 5 being the highest, right? And where you should place IDS, I think that's the most important question. So obviously in our case, remember we talked about segmentation, DMG is the best place to produce, right? So sometimes they will produce, they will put this sensor after the firewall or before the firewall. Okay, and there are pros and cons of doing both. So if you put it after the firewall, then you are not going to see the activity that firewall has blocked. Okay, you're not going to see that. Okay, and then you may have to coordinate with the firewall logs and stuff like that. Or sometimes you can put before the firewall. Okay, then you see all the activities. Okay, so the common deployment points are at the OT network parameter. okay, just inside the control network's firewall, okay, level 3, right? Or within the OT network itself, you are going to have a monitoring of a particular zone, right? So in our case, remember the conduits where so that's where the traffic is going from, say, one zone to another, and you may want to monitor that. So that will be a point where you will actually put the sensor, right? So, so that's again, you have to decide. And sometimes you may use multiple sensors. Okay, you may use more than one IDS, depending on, your network. Okay. We talked about the host-based IDSs. Okay, but I think if you are going to start with an IDS, it's preferable to start with the network-based IDS. Yeah. Verify. Yeah, obviously. Yeah, you need to verify that. That's actually a good point. Yeah. So if somebody is able to get into the IDS itself, yeah, yeah, that's possible. Because you are connected to the network. So the only way they can get to the IDS is through that port that you are mirroring, right? So if you can, because IDS itself doesn't issue any commands, it's just getting the information. No, see, the risk is very low because IDS is one direction, right? It's just looking at the traffic. Yeah. Yeah. So what? Yeah. So this is what IDS's role is. It's a passive system. Okay. So let's suppose there was some malicious activity happening. Okay. IDS will analyze that traffic. Okay, using one of these methods that we talked about, signature or anomaly, behavior, and all that, and flag it. It's up to the user to go back and look at it and say what really happened. Obviously, IDS will provide you the tools to do that, but it's not a protection system. It's not IPS. Remember we talked about too? It's not going to actively block anything. It's really one way. It's just looking at the traffic and giving you the information and the logs and so on. So obviously you have to process those logs and see. But it's very hard for IDS to be compromised unless you go in and introduce a malware yourself, right? From outside, the only connection is at that point where the sensor is, and that's also one way. You're just getting the information. Now, obviously, if somebody is able to, put something on the network and somehow IDS gets that through the traffic, then it's possible, right? But that's very, very hard to do that, right? Because it will analyze it as a, something of normal itself, right? Yeah. So it's like this. I tell you, I don't know if it's appropriate or not. You have to, there is nothing 100%. Okay. You are trying to make things difficult for cyber criminal. You can always, argue and say, if this happens, if this happens, if this happens, obviously it's going to happen, right? But yeah, it's one way.
what do you do? Because it is not going to take any action. For example, IPS got hacked.
Yeah, so yeah, then it's like any computer. Yeah, no, it's like any computer. Your computer gets hacked, then sometimes you are able to detect it through antivirus and so on. Sometimes you are not able to. Yeah, yeah, true. Which is those are the mechanisms. Just like your computer, you have antivirus, right? If it works, it will block it. If it doesn't work, then obviously you have a problem. So as I said, nothing is 100% guaranteed, but the risk for IDS getting compromised is very little. All it will do is it will stop being an IDS. That's it, right? In case of, that's why they don't use IPS that much, right? Because IPS is active, whereas IDS, at the most, what will happen? It will stop its functionality. And when it stops, obviously, you have to go back and check because there is nothing it can do to the system. It's passive. It's just sitting there and watching. Okay? Yeah. So these are again some of the points, at various points where you can have that. But as we talked about, the best place is the DMG, right? And again, you have to decide what are the critical points, what are the critical conduits. If you have done segmentation already, then obviously conduits are the best place to put these sensors, right? So I'm going to leave this with you. So this is what we were just talking about. They are in passive mode, okay, and not active mode, okay. And then where do you tap this? Okay. You are basically copying the the packets or the traffic to a sensor. Okay. So then you have to make sure you have the proper coverage, north south and east west. If it is a flat one, then you obviously have to do east west also. The whole coverage has to be done, right? So, and scalability is another one. So what are the deployment challenges for IDSs? Latency sensitivity, that's one. Although the passive one is not going to, impact that much, but you still have to check that even the passive monitoring does not overload your network. Even the little, thing does not, because you are now mirroring the port, so it doesn't impact, right? And then there is a legacy and proprietary systems. So you have to basically see that your protocols are supported, but if they are not supported, then you have a problem, right? And some of these outdated operating system and legacy protocols do not even have security, right? So they are insecure by design, right? So then IDS is even more crucial in those cases. Okay. So you have to use the IDS that basically understand these protocols, which are proprietary. Okay. So in a way, you may have to work with the vendor of the proprietary protocol, right, to understand that protocol. Okay. And then high availability and downtime, less downtime, right? You want 24/7 ideally. Okay. But obviously, if it gets compromised, then you can't have that, right? And then depending upon the method you use, especially anomaly based, you have to take care of your false positives. And that will require some tuning initially, at least. When you deploy it, initially it will require some tuning. So you have to allocate time and resources for tuning after deployment. So you have to analyze it and see if it makes sense, right? And then there are resource constraints, that utilities have, and integration with other operations. For example, um, the SIMEs, right? And any existing response processes, sequence of events and all that. So you have to kind of, connect that. So this is again some of the examples which I will leave that with you. Considering time, I think I better do a little bit of security auditing. Okay, so we will leave this one. It gives you the roadmap and so on, and best practices, right? So, and how does it help with the regulatory compliance? Okay, I've given you the example of North Americans, which is the SIP 015-1, where they need internal network security monitoring. Okay, so if you have IDS, you can fulfill that regulation there. Okay, I'm sure, as I said, you have the Indian equivalent of this. Okay, so I think I will stop here for this one so that I have a little bit of time to go over the security auditing, but we can have a discussion. Yeah. Activity. So you are continuously doing the security analysis, and it's more or less a real-time activity also, right? And it focuses on operational security, detecting anomalies, investigating events, and assessing risks as conditions evolve. Okay, and it uses basically logs, network captures, configuration snapshots, alerts, any information, and even information from IDS, if you have one, right? It will use that and then basically do the analysis for you. It's real time, 24/7 continuous. Whereas security auditing is a snapshot. Okay, you could do periodic, you could do annual or you could do semi-annual assessment of your security. Okay, it is focusing on the compliance mainly. Are you compliant with these regulations from the security point of view? Okay, it's very much evidence based. Okay, you have to show the evidence, configuration reviews, documentation checks, interviews, and so on. Okay, so for example, in the security auditing, you could say, are my firewall rules proper? Are they up to date? Right? Am I checking user access lists? Right? So it's very much a practice. Okay? Confirming backup and recovery testing has been performed in this case. So those are again some of the examples. Okay? They both have complementary roles. Analysis feeds the audit. Okay? Because if you have anomalies and incidents occurring, okay, you will identify them, right, through security analysis. Audits will strengthen the analysis. It's right. So this will include the recommendations for doing certain things. You could do enhanced logging, improved asset inventories, and access control, and so on. Right. So obviously, when you are just starting, the first thing is to do the audit. Right? So you will do the audit of your system, identify the weaknesses in security and the areas of improvement and all that. And then obviously your security analysis is continuous from there on. You are continuously looking at the logs that are being produced, any information that you get from the system that is being produced. So let's look at security auditing. I will skip the analysis part. We will go to auditing. And just for security analysis, the tools are actually very simple. For example, Wireshark, we talked about that yesterday. You could use that for deep inspection of protocol traffic, for troubleshooting and any forensic analysis. The same one Geek you could do for monitoring, right? That we talked about. And then this is vulnerability scanners. You can actually scan your network and find out the vulnerability in your network. Okay, right? So there is, Nessus is the one. This is the package we have used. And again, I'll share the paper that we have done for security auditing. So this was the one that we used. And then there is another one, OpenVAS. And this will allow you to scan your network and identify all the vulnerability. If there are any open ports, if they are properly configured or not. So all those issues it can identify. Okay. But obviously, the issue there is when you run these, uh, tools, you should not impact your operation. Okay. Either you run them during downtime, okay, when you are right, or when you run them, you have to make sure that your operation is not impacted, because obviously this is going to create the traffic. Actually, in the paper, if you are going to read that, you will see, how much traffic it generates and at what times and so on, right? So those packages are there. And then there are logging and analytics platforms that are available, which is Elk and Splunk. Splunk is actually very commonly used, which is a commercial platform, okay, for logging and doing the analytics, right? And then there are other tools for asset and configuration. But let's talk about auditing, okay? Analysis, as I said, is continuous. Auditing is periodic. It's structured and time-based. You can say every 1 year or 6 months, I'm going to audit my system for security, right? So, security auditing in substations, formal documented process, which basically looks at policies, controls, and procedures. Whether you have configured everything properly, you have proper policies, they are designed, implemented, and operating effectively over time. Okay. So what are your key objectives? Okay. Key objectives, again, from the security point of view, is that only authorized personnel have access to critical assets. The system configurations and rules are aligned. Okay. You have incident response, backup, and recovery processes. Those are all there. Okay. Because the recovery is equally important. Your incident may have happened, right? And then you are not running around with a headless chicken, not knowing what to do now, you know. So there has to be a process that if an incident happens, how you are going to respond to that. Okay. Although we didn't talk too much about that, but the recovery process is equally important, just like finding the problem. How will you fix it now? How will you respond? Right? So what are various phases? Audit phase is planning and scope definition, execution and evidence gathering, right? And then reporting and follow-up. Okay, so what are the audit methodologies that you can follow? There is a NIST framework-based audits, okay, which basically, does this: identify, protect, detect, respond, and recover. You have to have all those, uh, you know, functionalities in there. Okay. And then there is a risk-based approach where you prioritize audit focus on high impact systems, depending upon your risk level. You're going to do that. And then there is a checklist. You have a tailored checklist and say, okay, is my configuration okay? Is my, operating system up to date? Do I have all the patches? just a checklist of all the elements involved in the. So this is again a little bit more detail, and you can say could be used for a checklist or could be used on some of the other techniques. I'll show you three techniques that are used here. Okay, so for SCADA system auditing, you will do the configuration review, validate that only required protocols and services are enabled. Okay, uh, check segregation between different accounts, right? Or the patches applied according to the policy. Okay, and have you documented any exceptions? And what are the compensating controls? Let's say you decide not to apply a patch, okay, for whatever reason. So you have to say, okay, this is the exception and why we didn't do it and how we are going to compensate for that patch, right? Not applying. And then access control, we talked about that a lot, okay? Role-based access, right? So for ID auditing, you will check firmware integrity and versioning. Do you have proper versions? And do you have a proper inventory of what version of firmware you are running? Okay. Um, Obviously, you will check for any unsupported versions, right? And then confirm firmware is obtained from trusted source. We talked about, firmware being signed by a private key, right? So secure configuration standards, consistent settings, and communication interface audits, okay? So are properly secured and monitored. All the communication ports are properly secured and monitored, right? That's ID. So how do you do the scanning? I already mentioned the tool we talked about. Okay, you would do the topology analysis, segmentation we talked about, right? That they are segmented properly. And are there any uncontrolled connections between OT and IT networks? Okay, uncontrolled in the sense that you have no firewall, you have no control between IT and OT. Because most of the attacks that have happened on utilities actually originates from the IT side. Okay, and then they somehow propagated into the OT network. Okay, firewall rules properly done. Okay, you shouldn't have given access to some employee who has already left. Have you updated those or not, right? And then intrusion detection, we talked about that. There a, so this is, again, you can do this scanning and assessment using those tools, that we talked about. So those are again automated tools, Nasus and OpenBAS. Okay, so non-intrusive profiles, we talked about that. Test scans in the lab first. So usually that's what you will do. Okay, you will set up similar system in the lab and test it, right? And then we talked about that, scheduling those scans so that you don't impact the network otherwise, right? And then obviously you have to interpret the results, right? Okay. And the other one is configuration, access control, and logging audits, right? So configuration auditing, you will do the baseline comparison. You should have your gold standard configuration, that this is the best configuration, and then that becomes your baseline, and then you compare. Okay, there are automated tools for configuration draft, okay, which can pull, store, and different configurations for routers, switches, and firewalls, right? Then access control, we talked about the role-based many times. So review all accounts with access to OT, including external contractors. Okay, what are your authentication methods? password policies, and so on, right? And user actions are logged with sufficient forensics, right? So those are again the requirements. Okay, logging, there has to be a centralized logging system, right? Um, log retention, what is your retention period for logs? You know, is it 1 year, 2 years, 6 months, 3 months, right? So that has to be there. And log analysis for forensics, okay? Whether you are sufficiently doing the log analysis, right? So that's again, so those are, and then there is a separate for wireless, remote access, incident response, and physical security, right? So they actually have a use a modern encryption, WPA3, right? Wireless links. Are you using that or not? Check for any unauthorized or test SSIDs or MAC filtering. That similarly for remote access. Okay, what are your BPN policies? If you are setting up the BPN, okay, you know, if engineer is, you know, accessing remotely, say substation computer, via, it has to be via BPN. What are your policies? Is there a strong authentication? Are you logging who is getting in? Okay, and the least privilege. That's another. That's more role based. You know, you give them the least privilege, nothing beyond what they are supposed to have. Okay, this is again, once the incident happens, do you have a response plan? Okay, what happens if an incident happens? What is the playbook, and what is the, and who does what if an incident has happened, right? And then obviously regular testing has to be done. And then there is a physical security. You know, we talked about that a little bit. I think utilities are pretty good in that, in the physical security. Uh, third party risks, and these are again, um, you know, vendor who and contractors, right? So you have to have access scope control, limited vendor access to specific systems, contractual security clauses, you know, their own systems should have same level of security as you have, right? So, and verification of the controls at the vendor devices, right? So change management is another one, right? So any significant changes are documented, approved, and tested, and so on. So these are again very much common sense things. Okay, data protection and encryption, right? Do you have that in place, both for transit as well as for rest data? Is there a backup and recovery assessment? Do you have your configurations, databases, and logs? Are they backed up or not? Okay, and verify that restoration procedures are tested and documented, right? So, you know, just to give you small examples, these are again simple things. Many years back, actually, we did some work on power system restoration. Okay, this was a IEEE working group. And interestingly, there was one guy on that working group that I was chairing from California. They had an earthquake in California. All the power obviously bent down and everything. Now they're trying to restore the system. And guess what? Majority of the information about their system is on the laptops, on the computers. And some of those laptops are not charged. So one of the recommendations came out that keep those laptops fully charged all the time, right? So just simple things like that for recovery, right? So if an incident happens, you know, for the recovery, you need the information. So make sure those informations are available, right? So just simple things like that. So in the audit, that has to be identified, that is that happening or not, right? So, so this is again another area, monitoring patch management. Okay, so which devices protocols are monitored? So SIME system has to be in place, monitoring system, right? Patch and update management. Are you maintaining a inventory of patches and firmware on all your OT assets, right? And then training is another one, right? Security governance review, right? You will access policy coverage and so on. So, you know, is there management oversight of security matrices and incident review and so on. So again, this is very hard, security performance metrics and KPIs, okay? How did you quantify, right? So there are few areas you can say, what is my time to detect and respond to incidents? How much time it has taken me to detect. So that could be one of the KPIs, right? What are my patch compliance rates and how much, am I 100% doing the patches or 80% or 90%, right? So that's again could be one of the performance indices, right? Number of critical finding open versus closed over time, right? What are my critical findings that I'm doing? And training completion, what is my success rate, right? So those are again matrices. In that paper, we actually developed our own matrix, where the auditing we did for the system, we developed our own matrix, so you could. So this is again the integration of OT and IT, okay? Um, so physical cyber coverage, you know, correlating the incidents with, whatever information you have, could be CCTV footage, could be the batch activity, could be the cyber activity, right? So you have to correlate so that you can do a proper forensics, right? So are you doing that? That's again one of the audited things. And then there is endpoint protection in substations, okay? Um, So endpoint detection on engineering workstations or jump hosts that you are using or any supporting servers. So same thing for the IDS server. You have to actually do the endpoint protection there also, right? So that server by itself has to be protected, right, by whatever means you have, right? And then SCADA security protocol security audit, okay? So are these protocols that you are using, are they secure? You know, so then obviously we know that these are inherently insecure. Then you have to secure them by using, say, if you're using this by using IEC 62351, right? So are you enabling the authentication, encryption, and integrity check, right? So that again, firmware up and update lifecycle management, right? So are you keeping an inventory? We talked about that. Secure channels, right? And signed firmware to update, right? So sometimes you will do the update in the lab and verify that if you do that in the field, will it work or not? Okay. Sometimes, the manufacturers are very quick to provide updates. Okay. Sometimes they don't fully test it, or they don't have exactly the same conditions that you may have for your system, right? So it's important to test it in a lab environment before you do that in the field. Cloud-based is another one because a lot of now companies are using cloud-based services, right? Uh, so again, you ensure the least access, privilege, and authentication for whenever you are going to the cloud dashboards, you have to do that, right? Yeah. So let me just, so those are again some of the areas where you have to do this. Let me quickly uh, gives you the three tools or three mechanisms for security auditing. Okay, one of them is called STRIDE, which is a threat modeling framework in cybersecurity. Okay, which is again to identify and classify potential security threats. So this is what STRIDE stands for: spoofing, which is, you know, threat to authentication, because you are now pretending to be somebody else, right? And then tampering is another one, modifying data or code without authorization, right? So that's a threat to integrity. Repudiation, which is performing actions without accountability. So, right? Uh, I is information disclosure to unauthorized parties leaking information or sensitive data. D is denial of service, and E is elevation of privilege, right? So this is where role-based comes in. You you don't have access to something, right? But you know you are gaining permission to beyond your authority. That, right? So that's one. This was basically developed by Microsoft as a part of secure development life cycle for them. But this is one of the mechanisms that can be used to model potential threats, okay, and also prioritize mitigation for each type of threat. So that's one, STRIDE, okay. Then there are two others which are very commonly used. One is PASTA, okay, which is the process for attack simulation and threat analysis. Okay, you do audit basically by simulating attacks, and you know, and then you analyze your system, right? So this is a risk-centric, process-oriented, end-to-end attack simulation, and it's very comprehensive. Okay, the weakness, it's time sensitive and obviously needs the skills. You need to understand, what are the threats, what are the attacks you are going to simulate on your system, right? Then there is a dread, okay, which means damage, reproducibility, exploitability, affected users, and discoverability, which is also risk rating model, okay, and its focus is to prioritizing threats by severity. Okay, we will talk a little bit more about these. Okay, and it does a scoring, very simple scoring. I'll show you that. Okay, and it is very subjective scoring. That's the problem with this. Okay, so you have to basically decide what is important by for you. And then we talked about the STRIDE already. Okay, which is threat identification model. It's basically classifying and discovering the threats. Easy to apply. It doesn't prioritize the risk by severity. Okay. So what are the key differences between the three, PASTA, DREAD, and STRIDE? Okay. Purpose for PASTA is simulate and analyze attacks. Okay. The scope is business risk to technical attack, right? So it's more from the business angle. So what is the risk? Let's say an attack happens on a utility substation. What is the business risk for that? Okay. So if that substation is serving only 5 users, obviously business risk is very low. If that substation is serving a huge steel plant, the business risk is very, very high, right? So it basically goes from there, right? And its output is risk-based threat model. High complexity in this case. In case of DREAD, it is a scoring mechanism. Okay, I'll show you how they score that. Okay, and it looks at individual vulnerabilities, not really from the business, but more individual. Okay, and the STRIDE is basically identifying and classifying threats, okay? And it's a medium type process complexity, right? So those are three main ones that are used, and then NEST has its own framework. So how does it work? PASTA is more, define your business objective, as I already gave you an example, right? Define the technical scope, decompose the application, analyze the threats, analyze vulnerabilities, model the attacks, and do the risk and impact analysis. Okay, it's meant for large, high-risk applications, right? So that's DREAD has 5 matrices, and you are going to score each one of those. Okay, what is the damage potential of particular attack, particular scenario, right? Is it they go from 1 to 10 score, right? What is the reproducibility? Can that attack be reproduced over and over and over again, right? And same way, what is the exploitation that attack can do, right? Who are the affected users? Is it large number? Is it small number? Are the users very important who are going to be affected, and so on? Okay. And what is the scope of discovering that particular attack? Okay. Is it easily discoverable, or it will not be easily discoverable, right? So you score, everything from 1 to 10 in this case, and then you come up with the full score, right? So you will do this for every single possible scenario in your case, right? So, and the stride is 6 categories. We already talked about those, right? So where to use, right? So large enterprises, PASTA, quick threat triage is DREAD. And if you want the design, it's more for, developing systems. So stride, not really suitable for utilities, okay? And then there are others where you use stride and lightweight score. But let's look at their application to substation, okay? Right? Let's say, take a scenario, okay? We will quickly do this so that you get a little bit of idea about these. Okay, power station is using SCADA. It has field devices, RTUs, and PLCs. For example, it has engineering laptop, right? And it has perimeter physical access control. Let's just take a simple scenario. That's what power station has. Okay, so let's say we are now trying to do the security auditing of this. Okay, what will we do? So in case of PASTA, which is very much process driven, right? We are going to simulate attack paths and access the business impact. Okay, so the first step, remember the steps that we do. So define the business and technical scope. Business goal is obviously to prevent outage and protect grid stability, right? That's your overall business goal. And what are the assets? We already talked about those. Okay, data flow is from engineering laptop to VPN to SCADA to RT, right? That's how the data flow both ways, right? And step 3 to 4 are threat and vulnerability analysis. So the threats could be malware propagation into SCADA, could be via phishing. Most of the time, that's how it happens. Remote VPN compromise, right? Vendor account theft has happened. Vendor didn't take care of their account. And then there could be physical sabotage. So what are the vulnerabilities in this case? Okay, outdated firmware on RTU, right? Even if somebody gets in, right, through say VPN, if you have protected your devices, you are not that much vulnerable, right? You could be detected at that time, right? And shared VPN credentials and single flat network. If you didn't segment it, right, then you are much more vulnerable, right? And then step 5 to 7 is you're going to do the attack simulation and do the risk ranking, right? So malware in SCADA, likelihood is medium, impact is catastrophic, and risk level is very high. VPN theft, likelihood high. This is something you will decide, right? You know your system audit will decide that, right? Whether they, you have taken care of the VPN credentials, you have a mechanism in place and so on. If it is not high, then it could be low if you have taken care. Impact is critical, risk level is high. Physical parameter breach, low. Impact could be severe, medium, right? So then the output will be a risk ranked threat model linked to the business impact, right? So that's how you will analyze your system. And then you could, from there, you could come up with mitigation plans, right? After you have done the audit and done the risk analysis, you could say, okay, enforce multi-factor authentication, segment the networks, patch, and so on, right? These are just few examples. In case of dread, which is more subjective, you will prioritize identified threats by severity score. So malware in SCADA, okay? So those were the categories, right? Right? You remember those? Well, I don't expect you to remember those. But we talked about these, right? So then you give a score, D, 10, 8, and this is your total score, 43. VPN credentials, what are the issues with, let me just remind you what they are. I think I have to go way up. No, not that much up. There. Damage, reproducibility, exploitability, affected user discoverability, right? We talked about those. So, so you will give the, so what is the potential for damage and so on. So 44. So this is very subjective and you have to decide, for each category. Physical parameter, then. So then numerical ranking, but there is no modeling in this case, right? So somebody has to sit down and come up with these threats and say, how does it impact, right? And what will be the total score? So this is how you will audit and say, this is your score. And then obviously you have to come up with the strategies to lower that score in this case, right? So that, ideally 0, but very low, right? And in case of stride, identify possible threats. This is more threat modeling, right? We talked about that, right? So spoofing, can attacker gains VPN credential to impersonate vendor, right? So that has happened. Tampering, malware modifies RTU firmware, and so on. So, and output will be a categorized list of threats because it's threat modeling, and it will be useful for design reviews, but this is not mainly used for substation or power system security auditing. It's more when you are, say, developing a system. That's when you will use it. It originated, as I said, from Microsoft. Okay, so this is the side-by-side summary of all of these. Okay, and then NIST has its own framework. Maybe I'll give you that. It's a 2 pages I have. Okay, we will include it in your notes because it's mainly for North American. But I'm sure, um, uh, India has its own equivalent regulations. Okay, so for auditing, they have the list basically what need to be audited and so on. Okay, but this is, um, the 3 that are commonly used. Okay, as long as you are doing auditing, it's fine. So, identify the issues, right? So So PASTA is best for critical infrastructures. That's what is, mostly useful for the substations. Okay. DREAD is very quick because it's a, subjective scoring, so you could, very quick give a score in terms of, where you stand in security, right? Whereas STRIDE is finding out threats during design. It's more when you are developing the systems. Okay. So I think that's all I have. So we will include the two papers that I talked about and the NIST, list in terms of auditing, security audit. Okay. So you have any questions, quick questions about this? No? All good? Okay. All right. Thank you.